in today's lecture, people, we understand some special bonding cases. We will understand first about something called as back bonding and front bonding, and उसके बाद हम पढ़ेंगे a very special bond जिसे हम बोलते हैं banana bond. ठीक है, these are called as bridging bonds. चलो, now let's start with some special bonding cases. Now the first special case that we have is the molecule boron trifluoride, BF3. Now BF3 का people अगर हम hybridization करें, so boron atomic number 5, configuration was 2s2 2p1. ये ground state electronic configuration है. What do we write after ground state configuration? Excited state. And what we did in excited state configuration is we excited this electron, reconfigured its spin. And we get something like this. बराबर. एंड उसके बाद हमने क्या किया था? हाइब्रिड स्टेट. हाइब्रिड स्टेट में हमें क्या मिला था? व्हाट वाज द हाइब्रिडाइजेशन? sp2 हाइब्रिडाइजेशन. एंड उसके साथ हमारे पास एक वी हैड वन unhybridized, we have one unhybridized 2p orbital. हमने इसे बोला था 2pz. एंड यहाँ पे व्हाट वाज आवर हाइब्रिडाइजेशन? sp2. नाउ इसके बाद वी मेड इट्स ज्योमेट्री. हमने इसकी ज्योमेट्री क्या बनाई थी? Trigonal planar. This is boron, fluorine, and fluorine. But we can see here, people, boron का octet complete है क्या? No, it is not. It still has an incomplete octet. Now, why is this a special case of bonding? Let's understand this. If we observe boron and fluorine, by just looking at the structure, it feels as if boron and fluorine have a single bond in between them. I repeat, boron and fluorine has a single bond. So the bond length should have matched with single bond length. But experiment से पता चला the bond between boron and fluorine is stronger than expected, and the bond length is smaller than a single bond. And not for one particular, for all the three bonds. Now that was strange. हमारा theory says it should be a single bond, but experimental data shows that the bond is not a single bond. It's actually smaller than a single bond. It's stronger than a single bond. So let's understand what was happening. Fluorine has 3 lone pairs. Okay. Now, each fluorine here has 3 lone pairs, and at the same time boron has an unhybridized 2p z orbital. It has an unhybridized 2p orbital. ये है unhybridized, which means this is empty. (2p) orbital. Now boron क्या बोलता है फ्लोरीन को? फ्लोरीन, you have 3 lone pairs. एक lone pair मेरे साथ share करना. So these lone pairs, fluorine shares with boron, and we have what is called as a pi coordinate bond. So try and understand यहाँ पे क्या हो रहा है. Boron and this fluorine, the first fluorine, they not only have a single bond, but fluorine ka one of the lone pairs is being shared by fluorine with bromine. Did you people get that? What is this bond called? It's called as a pi coordinate bond, या हम इसे भी बोलते हैं lone pair and p orbital conjugation. I repeat, lone pair. This is lone pair. This is empty p orbital. Empty p orbital conjugation. But people, do you think fluorine is happy sharing its lone pairs? What is the nature of fluorine? Highly electronegative. ये fluorine क्या बोलेगा थोड़े टाइम के बाद? I want my lone pairs back. The moment ये fluorine says I want my lone pairs back, what will boron do? It will request the next fluorine for electrons. See, the reason you putting a dotted line, it's not a permanent bond. Getting that? इसलिए we're putting a dotted line. After a while, ये fluorine भी क्या बोलेगा? I want my lone pairs back. Then what happens? And this keeps on happening. This phenomenon is known as resonance. So lone pair p orbital resonance भी आप बोल सकते हैं इसे. And if you observe carefully, when boron does this, it completes its octet. Now if boron can do this with fluorine, it can also do this with other halogens. For example, boron can do this with chlorine. Boron can also do this with bromine, and boron can also do this with iodine. But the problem is, as you go from left to right, I repeat, as you go from left to right, I mean starting from fluorine to chlorine to bromine to iodine back bonding, the extent of back bonding decreases, or the back bonding strength decreases. So the strongest back bond is BF3 followed by BCl3 followed by BBr3 and followed by BI3. Now why is this happening? The reason is, if I look at boron, the 2p orbital of boron was forming a back bond with the 2p orbital of fluorine. So ये भी 2p है, ये भी 2p है. Actually speaking, both should be of the same size. So same orbital overlap हो रहा है यहाँ पे. 2p is overlapping with 2p. But when you go to BCl3, 2p is overlapping with 3p. When I go to BBr3, 2p is overlapping with 4p, and over here 2p is overlapping with. So as the size of the orbital increases, the overlapping decreases, or the extent of overlapping will decrease. And that is why as you go down the group, so halogens के, the extent of back bonding will decrease. एक और पैरामीटर हमें याद रखना है, strength of Lewis acid. The Lewis acid strength will be exactly the opposite. Bi3 will be the strongest Lewis acid. Now we may not understand what is the meaning of Lewis acid. I would just like to give you a small brief कि Lewis acid का मतलब क्या है. Though we'll study this in more detail आगे, हम थोड़ा basic कर लेते हैं. Till lower standards, what is an acid? An acid is something which donates H plus. So according to Arrhenius theory, that what we have studied till lower standard school में, acid will donate H plus in solution, base will donate OH minus in solution. But NH3 ammonia is a base, and is there any OH in ammonia? So what makes ammonia a base? And hence हमें एक और theory चाहिए जिसको हम बोलते हैं Lewis theory. According to Lewis, acids are electron pair acceptors, base are electron pair. So someone who's giving pair of electrons is a base, and someone who's accepting pair of electrons is an acid. So over here, fluorine is donating or giving or sharing its lone pair of electrons with boron. तो boron बन जाता है आपका Lewis acid, and fluorine becomes Lewis base. Along with this theory, there is one more theory जिसे हम बोलते हैं Lowry-Bronsted theory. According to Lowry and Bronsted, acids are proton donors. Proton donors is just like saying acids give H plus. So ये और ये same है. And base are proton acceptors. So for the time being, this is more than enough. बाद में हम in detail करेंगे when we do equilibrium. Did you people get that? ठीक है? And hence, if I see in Bi3, the extent of back bonding between iodine and boron will be very poor. And that is why boron का वो p orbital would more or less still be empty, and it would want electron pairs, making Bi3 the strongest acid. And BF3, since the extent of back bonding is very strong, the boron over here does not really need electrons now, and hence it's a very poor Lewis acid. Did you will understand this? BF3. Chalo. Let's move on to the second example. Now, the second example that we have is इस कंपाउंड को हम बोलते हैं ट्राइमीथाइल amine. Okay, now if I want to know its hybridization and its geometry, it is somewhat similar to ammonia. Ammonia, what was the geometry of ammonia? It was trigonal pyramidal. यहाँ पे आपका वो लोन पेयर था, and instead of H यहाँ पे हमारे पास क्या है? CH3 and CH3, trimethylamine. Can someone give me the hybridization? यहाँ पे नाइट्रोजन की hybridization क्या थी? sp3, and geometry was trigonal pyramidal. CH3 comes from CH4. CH4 क्या होता है people? मीथेन। अब मीथेन से रिमूव वन हाइड्रोजन, क्या बन जाएगा वो? CH3। सो द रूट तो सेम है, बट आगे आप सफिक्स लगा देते हो YL, हेंस मीथाइल। नो कार्बन फैमिली में कार्बन की नीचे जाओ, व्हाट्स बिलो कार्बन इन द पीरियोडिक टेबल? सिलिकॉन। इफ आई पुट SiH4, now if I try इसका nomenclature ANE, I put ANE and silicon SIL. Now what's the name of this compound? Silane. Now remove an H from silane, SiH3, that becomes SIL, Silyl. Okay, the reason we are writing this is, now I can make, just like we have CH3 thrice N, I can write SiH3 thrice N. Can someone try इसका nomenclature? Trisilyl amine, Silyl amine. Everything looks the same. So geometry क्या होनी चाहिए थी यहाँ पे भी? Pyramidal, and the hybridization sp3 and the bond angle. Anyone remembers bond angle over here? 107.5, somewhere around 107 degree bond angle होना चाहिए था in tricylilamine. But silicon belongs to the third period, and carbon belongs to which period? It belongs to the second period. यहाँ पे silicon belongs to the third period, and third period elements have empty D subshell. Excellent. They have empty 3D subshell. And यहाँ पे they have, उनमें तो D ही नहीं है, empty होने की बात ही नहीं आती. Now what happens because of the empty D subshell is nitrogen, ठीक है, ये आपका नाइट्रोजन का लोन पे this is the empty D. Nitrogen is now giving electrons to silicon because silicon has an empty 3D. Now let's understand this. In BF3, the side attached fluorine was giving electron to the central atom boron. I repeat, fluorine side में थे and it was giving electrons to the central atom. I repeat, side में giving electrons to the central. But in trisilylamine, the central atom is giving electrons to the side attachments. इसको हम बोलते हैं front bonding. Which form of front bonding is this? The lone pair is going into the D orbital, or you can see that this front bonding results in the temporary formation of a p-pi d-pi bond. Now look at the shape. The shape कुछ ऐसे हो जाता है. first it will bond with this Si, second time में किसके साथ people, the next Si, and this will continue. टेक्नोलॉजी है, ठीक है. Now tell me people, can someone give me इसका shape क्या है? Trigonal, planar. Bond angle please. 120 degrees. तो यहाँ पे the shape becomes trigonal, planar. And the bond angle 120 degrees. Did you will understand this? Yes or no? Chalo, let's move on to the next special case. The next special case is CH3 twice O. CH3 twice O को हम बोलते हैं dimethyl ether. Ether is a functional group, I'm sure which you people have heard in organic chemistry, or this is also called as methoxymethane. And we are going to compare this with SiH3 twice O. If this is dimethyl ether, इसको हम क्या बोल सकते हैं? Disilyl, though that is not the exact name. इसके अलग अलग थोड़ा नाम याद रखना, सिलोक्सेन या सिलिल ऑक्साइड या डाइसिलिल ऑक्साइड. Same thing again over here. Will there be oxygen and carbon के बीच back bonding? Will there be any back bonding between oxygen and carbon? If we go back here, instead of nitrogen, I've just put oxygen. Was there back bonding between nitrogen and carbon? No back bonding. Why? Because no availability of d orbital. Was there back bonding between nitrogen and silicon? Yes, because empty d orbital available. Similarly, in dimethyl ether or methoxymethane, there is no back bonding, or I'm sorry, no front bonding. There is no front bonding. Geometry कुछ ऐसा है, CH3O CH3, ये आपका एक लोन पेयर, ये आपका एक लोन पेयर. ये bond angle is how much? Hybridization sp3, दो sigma, दो lone pair, so the geometry is bent or V-shaped. Bond angle 1 degrees. Okay, the bond angle in ethers is 1 1 1. Exactly यहाँ पे होना चाहिए था. But the problem here, I would not say problem, but the change over here is between Si and O. There's going to be a d orbital, so empty d orbital. So SiH3O SiH3, यहाँ पे एक back bond, and in the second case there's one back bond here. This is your continuous resonating form. though the hybridization is sp3, the geometry is bent, the bond angle over here is around board hang हो गया. Okay. Now in Disilyl oxide, the bond angle here is around 144 degrees. ठीक है? चलो. Now let's move on to the next example. Next special case. The next special case that we have is इसको हम बोलते हैं मिथाइल isothiocyanate and what will you call this as? Silyl isothiocyanate. Again, we will everything exactly remains the same, no difference. Nitrogen पे यहाँ पे क्या है? Lone pair of electrons. But carbon के पास is there empty d orbital available? No, there is no empty d orbital available on carbon over there. And hence this will remain. तो मैंने इसको बनाया straight है, it's actually a bent molecule. ठीक है? I repeat, it will be a bent molecule, but over here there will be back bonding between nitrogen and silicon, and hence this molecule becomes linear. I repeat, sorry, pardon me, not back bonding, इसको हम क्या बोलेंगे? Front bonding. Not only that, it also changes the hybridization. Because of that, यहाँ पे hybridization becomes sp और यहाँ पे hybridization है nitrogen पे sp2. Did you will get this? चलो. I see there are different examples. Now the next example that we have is so again you have an ether, but over here we have aluminium, and instead of CH3 we have CF3. Now ये concept includes a certain concept of organic chem. So we may not get some parts here and there because organic chem का हमने वो part अब तक किया नहीं है, but I'll still try and explain as much as possible. Again, the molecule here, oxygen is sp3 hybridized, दो lone pair, दो sigma bond. So we know that the bond angle should be somewhere around 104 degrees because we've learned that in sp3 hybridization. But what happens here is fluorine is highly electronegative in nature. So fluorine has a certain property जिसको हम बोलते हैं negative inductive effect. what is negative inductive effect? It's the tendency to pull sigma bond electrons towards itself. जैसे थोड़ा electronegativity में हमने पढ़ा है, तो ये फ्लोरीन क्या करता है? ये जो electrons है, it starts pulling it towards itself. Now those electrons which are pulled towards fluorine, they start attracting these electrons. So it's like ये तो 3 fluorine atoms है, they are pulling electrons not only from carbon but also from aluminium. So the molecule should have been bent. ये बीच में oxygen, aluminium and aluminium, and यहाँ पे carbon and with fluorine. Molecule ऐसा होना चाहिए था. But because of that fluorine who's pulling the electrons towards itself, it's like it's pulling the entire molecule apart. And hence ऐसे bent होने की जगह पे it becomes almost linear molecule. I repeat, this becomes almost linear where the bond angle is around 178 degrees. Did you people get that? That's special case number 5. Next. What you have over here is an alcohol, R3COH, और हम इसको ऐसे लिख सकते हैं CH3 something like this. Now these alcohols in general are very poor acids. I repeat, they are very poor acidic nature. But if you compare the same with instead of carbon, we now have over here silicon. Same thing. क्या होता है? There will be back bonding between the empty d orbital of silicon and the lone pairs available on nitrogen. These lone pairs will be shared with silicon, as a result of which it will develop एक double bond character ऐसा. So oxygen which had 2 lone pairs, one of the lone pair is being shared with silicon, and hence ये bond will be easily broken and released in the form of H+. The same bond here won't be that easily broken because there's no need for oxygen to break the bond, as oxygen has its lone pairs with itself. Oxygen अपने lone pairs किसी को नहीं दिए यहाँ पे. But what has happened here, one of the lone pair is currently in conjugation with the empty d orbital, as a result of which the electronegative nature of oxygen यहाँ पे थोड़ा trigger हो जाता है and it wants its lone pairs. तो अगर ये वाला नहीं मिल रहा है, what oxygen does is it breaks this bond and hence making this more acidic when compared with R3COH. So these are some special cases of bonding, especially some cases of back bonding and front bonding. यहाँ पे भी if you see oxygen is giving, तो इसको भी आप एक front bond बोल सकते हो. हम pardon me, back bond बोल सकते हो. Side attachment से electrons are coming to the central atom. Did you will get that? चलो. Okay, now using the concept of back and front bonding, let's look at this question. Question क्या बोलता है? Compare the acidic character of CHCl3. CHCl3 stands for people chloroform. ठीक है, and CHF3 fluoroform. अब एसिडिक कैरेक्टर मतलब क्या है? देखो ये आपका क्लोरोफॉर्म है एंड ये आपका फ्लोरोफॉर्म. एसिडिक कैरेक्टर मतलब ये दिस विल बी रिमूव्ड इन द फॉर्म ऑफ H+. सो जैसे ही H+ निकलेगा, कार्बन विल हैव अ लोन पेयर and chlorine, chlorine, chlorine. Same thing will happen here. With this H+ removed, carbon, fluorine, fluorine and fluorine. ये lone pair. Now this lone pair here can be delocalized in the empty 3d orbital of chlorine. So chlorine has this empty 3d. और ये जो लोन पेयर है यहाँ पे, ये यहाँ पे delocalize हो सकता है. Not only with this chlorine but with this chlorine and with this. Now no such delocalization or no such front bonding is possible in CF3, and that is why CHCl3 is a stronger acid compared to CHF3. ठीक है, this concept similarly comes from here. ये वाला using front and back bonding हम acidic character भी compare कर सकते हैं. Okay, चलो. Now, so these were some special cases. Now we study a very special bond जिसे हम बोलते हैं banana bond, या हम we are studying what are called as bridging bonds. Now let's understand what do you mean by bridging bonds. Okay, now let's say I want to know the hybridization for BH3. BH3 stands for borane. Now borane, boron, atomic number 5, last shell configuration 2s2 2p1. This is which state configuration? This is ground state. Ground state configuration के बाद we reach excited state. What we do in excited state? हम यहाँ का एक इलेक्ट्रॉन यहाँ शिफ्ट करेंगे. The spin will be normalized and then we have something called as hybrid state. Hybrid state में these three will hybridize, these three orbitals they hybridize. कौन सा hybridization है people ये? sp2. और यहाँ पे we have empty unhybridized (2p) और ये हो गया आपका sp2 hybridization. What is sp2 hybridization geometry? Trigonal planar. So if I look at BH3 carefully, BH3 is trigonal planar, but there is a problem here. Even this has an incomplete octet. So this is Lewis acid. Now, had this been BF3, तो back bonding होता, because fluorine has lone pair of electrons, but there are no lone pairs available on hydrogen. So basically there is no back bonding possible over here. So how does BH3 stabilize itself? BH3 stabilizes itself by a phenomena which is called as dimerization. Di means two, mer means unit. So how does BH3 stabilize itself using dimerization? Let's understand that. Now what happens here is boron, this is the first boron atom. You have a hydrogen here and you have a hydrogen here. Remember, it is BH3. So there's a third hydrogen. I'm just writing that hydrogen over here. And the two electrons to form a bond, these are the two electrons. I'm not making that bond. Now comes in one more BH3. I repeat, एक और BH3 है, so B. And there's one more hydrogen. So it's I repeat, one hydrogen is over here, one is over here. This is the third hydrogen and uske electrons. Now with me till here. Now see what happens. Ye boron and ye boron are sharing the two electrons with each other. I repeat, they are sharing the two electrons with each other. So boron, and hydrogen, these three atoms are sharing these two electrons. This bond is called as a banana bond. Okay, also called as 1, 2, 3. 3 center 2 electron bond. I repeat, it's called as 3 center 2 electron bond. And similarly, the same thing happens over here. So even this is a banana bond. It looks like a banana, so it's banana bond. Now, banana bond is perpendicular to the plane. These 4 bonds, 1, 2, 3, 4, इनको हम बोल सकते हैं 2 center 2 electron bonds. All the 2 center 2 electron bonds are in the same plane. The banana bonds are perpendicular to the plane. So like banana bond niche and banana bond upar. Did you people get that? And hence BH3, so 2 molecules of BH3 becomes B2H6. This phenomena is called as dimerization. Did you people understand what's a banana bond? And a simple way you can also draw it like this. So you have B this is the banana bond. Getting that? The green bonds are in the same plane. And white bonds are actually perpendicular to the green ones. Now, similar to this, I can also make instead of boron, I change that to boron ke niche we have aluminium. So the molecule becomes Al2H6, just like we have B2H6. Exactly the same configuration can also be shown by Al2H6. Getting that? Let's take one more example. Molecule like Be2H4. Be2. 4 hydrogens. There's one here, one over here, and banana bonds. This is the structure for Be2H4. These two molecules are non-planar because the green bonds are in one plane, H and H wala bond is in different plane. Be2H4 is a planar molecule. These are called as bridging bonds. These are the first set of cases. Now, next, we did a molecule AlCl3. Let's quickly go back to its hybridization. Aluminium, atomic number 13, last shell configuration 3s2, 3p1, ground state. What happens in excited state? फिर से हम क्या करेंगे? Shift 1 over here. So ये हो गया आपका excited state. Give me hybrid state. Hybridization क्या है? sp2, and we have one unhybridized (2p) orbital, and यहाँ पे hybridization is, if the hybridization is sp2, what is the geometry? Trigonal planar. So people, if I look at AlCl3 in gaseous state, the hybridization is sp2 and the geometry is trigonal planar, which is like this: Al, Cl, Cl and Cl. But does aluminium have a complete octet over here? Do you see a complete octet? No, we see only 6. And hence, in its solid state, look at AlCl3. This is AlCl3. Each chlorine has how many lone pairs? 3 lone pair. Comes one more AlCl3. With each chlorine having 3 lone pairs. And now observe carefully what happens. Aluminium has an unhybridized 2p orbital. यहाँ पे chlorine has lot of lone pairs available. ये aluminium ये chlorine को क्या बोलता है? Please, can you share one of these lone pairs with me? And results in the formation of a coordinate bond. Similarly, this aluminium tells ये वाला chlorine Can you share one lone pair with me? Results in the formation of a, and what we have here is Al2Cl6. Basically, AlCl3 forms a dimer. I repeat, di means 2, mer units. 2 units are coming together, and hence AlCl3 in solid state becomes which hybridization? sp3. So in solid state it becomes an sp3, in gaseous state it becomes an sp2. Now the question that one should ask here is, why is there no back bonding? Why is AlCl3 forming a dimer? Why didn't AlCl3 do this just like BF3 did? एल्यूमिनियम के पास एम्प्टी ऑर्बिटल है, क्लोरीन के पास लोन पेयर है, form a back bond. Why is there a need to form a dimer? The reason for that, it is difficult to form a back bonding with 3 chlorines around and aluminium. There is a lot of repulsion, you can say that. तो यहाँ पे back bonding is not sustainable, and that is why it forms a dimer rather than a back bond. And similarly, just like AlCl3, we did BeCl2. Beryllium, atomic number 4, configuration 2s2 and 2p 0. 2s has how many electrons? 2. 2p has how many electrons? 0. This is which state? Ground state. Ground state say we go to excited state. Excited state mein we have 1 electron over here and we have 1 here. क्या मिलता है hybridization में? sp, or hybrid state is this, and we have unhybridized (2py and 2pz बोल सकते हैं, and this is which hybridization? sp hybridization. What is the geometry? Linear. So if you look at BeCl2 in gaseous state, it is sp with linear geometry. But the same BeCl2 in solid state becomes, and let's understand, yehi BeCl2, this is Be, this is BeCl2 number 1, number 2 and number 3. If you look at this BeCl, the first lone pair from this carbon, because there are, remember, 2 empty and एक और empty था, it takes or it borrows from this carbon. Now it has 4 sigma bonds around it, and this continues. This is a chain which continues, and hence in solid state it has what is called as a polymeric form. Did you people get this? Okay. So these are some more examples of bridging bonds. Baki, I'll share some notes. You can copy that. I'll also share a table on the group. Make sure you copy that. Okay. So we stop here for today. We will continue with chemical bonding next class.